Welcome to my channel Mathematical Clinic of Subash. Today we are going to discuss the very important topic of mathematics, conic section. We can define conic section by two ways. Conic section can be defined as the intersection of plane and cone as well, whereas we can define conic section on the basis of locus. Today in this lecture we are going to define conic section on the basis of locus of a moving point. Actually, we are going to take a fixed point here. Suppose S is the fixed point and a fixed line. Suppose this one is the fixed line. Suppose there is a moving point. This P is the moving point, and this moving point moves in such a way that this is the moving point one. So it moves, and it moves in such a way that the ratio of this distance and this distance. Suppose this one is n. The ratio of this distance and this distance means SP upon PM is always constant. Constant means equal. If this point P comes here, then also this distance SP by PM, the ratio SP by PM will be same as the ratio SP by PM here. Everywhere, if comes here, then also this SP upon PM will be same as SP upon PM in the previous cases. If this point P moving point moves in such a way that this ratio PS upon PM is always constant, always equal, then the path so made is called a conic section. Suppose this is the path made by that point. This is the conic section one. This path is the conic section one. So conic section is the locus of a moving point which moves in such a way that the ratio of its distance from a fixed point, this one is the fixed point one, and this one is the fixed line one. The ratio of distances from fixed point and fixed line is always constant. By the similar manner, there may be this type of figure. This is also a conic section. We call ellipse. There may be this type of figure. This is also a conic section. Here also we can see same thing. Suppose this one is the fixed point S and this one is the fixed line S. Here's the moving point. If point P moves in such a way that this distance SP by again here PM. SP by PM is constant. SP by PM is constant, and it is a conic section. This one is also a conic section. This one is the we know this one is the hyperbola one. This one is also a conic section. Suppose this is the fixed line and this one is the fixed point, and this one is the moving point one. Again the distance SP by PM is constant everywhere. If it is a conic section, then the ratio of distance from fixed point and from a fixed line is constant. So we are going to define a conic section on the basis of the locus of a moving point. It is the locus of a moving point which moves in such a way that the ratio of its distance from a fixed point and from a fixed line is always constant. That I am going to write here. A conic section is the locus of a moving point which moves so that ratio of its distance from a fixed point and from a fixed line is always constant. Don't forget, this fixed point is called, this one is called focus of the conic section, whereas this line, fixed line, is called the directrix of the conic section. First of all, what is conic section? It is just a locus of a moving point which moves in such a way that the distance SP by distance PM is always constant, always equal. This point, fixed point 1, S1, is called focus, whereas the fixed line is called directrix. And this ratio, SP upon PM, is called, this constant ratio is called eccentricity. Eccentricity is always denoted by a small d. So, how can we define eccentricity? In the conic section, the constant ratio. What ratio? Ratio means ratio of distance from a fixed point, and from a fixed line is called eccentricity. Now we are going to classify conic section on the basis of eccentricity. In this case one, this SP and PM is called constant. If it is a parabola, then SP by PM equal to 1, always 1. It means the distance from fixed point is equal to distance from fixed line. If eccentricity is 1, that I am going to write here. If E equal to 1, what is E? E is SP by PM. This one is 1. If you do the cross multiplication, SP will be equal to how much? PM. So if distance from fixed point is equal to distance from fixed line, then it is parabola. It is a parabola. In second case, if this eccentricity is smaller than 1, means again eccentricity is how much? SP by PM. SP by PM is smaller than 1. Let us do cross multiplication. SP will be smaller than how much? PM. So what is SP? SP is distance from fixed line, and what is PM? PM is distance from fixed line. So if distance from fixed point, this one, is smaller than distance from fixed line, this one, then the conic section so come is called, it is an ellipse one. It is an ellipse. If eccentricity is smaller than 1, that is the distance from a fixed point is smaller than distance from a fixed line, then it is an ellipse. And we are going to move to the third case. If eccentricity is greater than 1, what is eccentricity? Eccentricity is SP divided by PM. SP by PM is greater than 1. Let us do the cross multiplication. SP is greater than PM. It is a hyperbola. Now I am going to summarize. First of all, what is conic section on the basis of the locus of a moving point? It is a locus of a moving point which moves in such a way that ratio of its distance from a fixed point and from a fixed line is always constant. What is the fixed point one? It is focus. What's the fixed line one? It is directrix. What's the constant ratio one? SP by PM one. It is eccentricity denoted by small e. We learned that if eccentricity is 1, exactly 1, then this distance will be equal to this distance and it is a parabola. If eccentricity is smaller than 1, then this distance SP will be smaller than this distance PM1 and it is an ellipse. If the eccentricity is greater than 1, it means distance SP is smaller than distance how much? SP is greater than the distance how much? PM, then it is a hyperbola. So there are 3 types of conic section we have discussed here. They are parabola, ellipse and hyperbola. In the case of parabola, eccentricity is equal to 1. In the case of ellipse, eccentricity is smaller than 1, and in the case of hyperbola, eccentricity is greater than 1.